Alright guys, we are going to jump into our inverse trigonometry lesson, section 5.5, and we begin by considering our graph of our parent function for sine of x. Now, I've taken the liberty of drawing our normal one cycle of our parent function from 0 to 2 pi. I also, and you'll see why in a little bit when we get talking about inverses, I've also labeled back to negative 2 pi to show you A, that if we remember this graph, will go on forever. And also for a very important part of inverse trigonometry. Okay? Now again, that's just part of the sine graph. It does go on infinitely in both directions. Our first question to try to tie this parent function into our inverse lesson is, what is the domain and range of this function? Well, the domain is all real numbers, negative infinity to positive infinity. Our range, negative 1 to 1. We've known that for a long time. Then we get this question, is it a 1-to-1 function? So for years, you guys know the definition of a function. Basically, does it pass the vertical line test? For every input, is there only one output? Okay. We can also say that a function is 1-to-1 if every output, there is only one input. For every y, there is only one x. That would be the definition of a 1-to-1 function. How would we know that? It would pass the horizontal line test. Is this a 1-to-1 function? Absolutely not. First of all, it is a function. It would pass the vertical line test as infinitely as we want to go, but it certainly would not pass the horizontal line test. There are a bunch of x's at the y values that I'm kind of mirroring right here. Okay, so no, it doesn't. All right, that's important. Okay, we'll get to on kind of the fourth question here. Why do functions have to be 1-to-1 to work with inverses? But here's the question: what could we restrict the domain to so that the function is 1-to-1? All right, now we want to, when we're thinking about how to restrict a function so it is 1-to-1, we want to make sure we get all of the range. So we want to get points from -1 all the way to 1, okay? But we don't want them to duplicate, all right? And so basically what we're asking is, where are we going to look at this function to even consider its inverse? And for the sine graph, we are going to look here, from -pi/2 to pi/2. If we restrict the sine graph to between these points, we get every one of sine's y values. At some point along this portion, there is a y value from -1 to 1. All of them are included, okay? And it becomes a 1-to-1 function. It would pass the horizontal line test if we look basically from here to here. So we are going to restrict the domain from -pi/2 to pi/2 to make it a 1-to-1 function. All right. Now, before we get to number 3, I know we're going out of order a little bit. Why do functions have to be 1-to-1 to work with their inverses? Okay, well, we need inverse of functions to be, drum roll please, a function. And if a function is not 1-to-1, then the inverse of that function won't be a function at all. Okay? If we flip the x's and the y's, one of the perfect examples of it would be something like a quadratic, a parabola. Okay? This is not 1-to-1. If we were to draw the inverses, okay, which would be the y and the x, switch the x's and y's, all of a sudden we get something here that is not a function at all. And we've talked, and you've learned in many different math classes, why functions are important. You know, if we're using mathematics in the real world to model situations, and we're dealing with something that's not a function, then if I ask you at, I don't know, whatever the independent variable is, what's going to happen with the dependent variable, and you come back to me and say, oh, it's going to be one of those two things. Well, that's not what we need math for. We need math to be able to give models a predictive value of being exact. Okay, so that's a little bit of a throwback of why functions are important. And the reason we need to have one-to-one functions to consider inverses is so that the inverse is actually a function and we can deal with it. We know what we're dealing with here. Okay? What is the domain and range of the inverse function with this restricted domain? Okay? Well, our new domain for our restricted piece, negative pi over 2 to pi over 2, and our range still negative 1 to 1. Well, if we switch x's and y's for inverses, then the domain of our inverse function would be negative 1 to 1, and our range negative pi over 2 to pi over 2. We're going to talk about kind of inputs and outputs and how trig and inverse trig relate to each other momentarily. Okay? And this was, in the classroom, usually it lands a little bit better. It sinks in. We do a little bit more with this. But I just wanted to basically show you this whole first page is about, how do we restrict a function that isn't one-to-one to make it one-to-one to be able to consider the inverse of it. Okay? So I wanted to give you that background before we jump into kind of what inverse trigonometry is. Okay? First, regular trig, if you will, we're asking you the input. If we're doing sine of pi over 4, the input is an angle. We've been working mostly with angles on the unit circle. What would the output of this be if we asked you to evaluate sine of pi over 4? This would be a trig value output. The value, the sine value of pi over 4 is root 2 over 2. That was a question we asked you in the first two sections of this. Inverse trig, okay, inverse that, raised to the negative first power is the symbol for inverse. So let's consider this. In an inverse problem, instead of our input being an angle, our input's going to be a trig value. Let's say 1/2. That is a value input. This value happens to be on the unit circle, and our output is going to be an angle. It is the reverse of, or the inverse, pun intended, of what we did in sections 5.1 and 5.2. Instead of giving you the angle and asking you for the sine, cosine, tangent values, we're going to be giving you the sine, cosine, tangent values and asking you at what angles does that occur. But what angles do that occur at specific domains? Like sine, we just talked about from negative pi over 2 to pi over 2, which would be negative 90 to 90. Okay? A couple different properties of inverse trig. We have two different types of notations. We have inverse notation. For example, sine inverse. This means we want to be working in degrees. So our output would be in degrees. If we did sine inverse of root 2 over 2, your answer should be 45 degrees. We also have arc notation. It means the same thing. Arc sine. Okay? This means we want to be working in radians. So if we asked you for arc sine of root 2 over 2, remember value input, question you're asking yourself here is, at what angle between negative pi over 2 and pi over 2 has a sine value of root 2 over 2? Lucky for us, same question, same answer, different unit of measurement because of the two different types of notations. right. Cool. So two important things from this box: understanding the notations and whether we're working in degrees or radians, and understanding the difference between evaluating a trig function, sine of pi over 4, give you the angle, ask you for the value, and an inverse trig function, evaluate inverse sine of 1/2, give you the value, tell me what angle that occurs around the unit circle. We restrict the domain of cosine and tangent because all of these trig functions go on forever. I don't want to get back into on a video drawing cosine, drawing tangent, just like we did sine, and highlighting where we make it 1-to-1. So I'm just going to give you the restricted domains, but it's for the same reason. Okay. 0 to pi or 0 to 180 for cosine inverse, and tangent inverse is the same as sine. Negative pi over 2 to pi over 2, or negative 90 degrees to 90 degrees. Okay. And the last other one we should probably consider here is the quadrants. Okay, negative 90 to 90 is quadrant 4 and 1. That gives us the negative sign values and the positive sign values. For a restricted domain for cosine, thinking of its inverse, first quadrant gives us our positive values. Second quadrant, from 90 to 180, gives us our negative. Tangent, again, same as sine. Okay. So let's do a couple practice problems together. All right, what I want to do is we're going to go through a thought process of what this question is asking us for, and we're actually going to write it down here on this first one. It says evaluate the following inverse trig functions. This says inverse sine of 1/2. Okay, so we need to look at notation. We need to look at value. So this is asking us what angle between, should we be working in degrees or radians here? This is the inverse notation. We should be working in degrees. What angle between sine negative 90 to 90, between negative 90 degrees and 90 degrees, has a sine value of 1/2? That is what this question is asking you. Think of your unit circle. First of all, sine value is positive, which means we're going to have a quadrant 1 value if we can only choose from negative 90 to 90. So now we've limited even more. We're looking from 0 to 90. And your knowledge of the unit circle should tell you that 30-degree angles have sine values of 1/2. Arc cosine of negative root 3 over 2. What angle between, all right, it's arc notation, so we want radians. Cosine, restricted domain 0 to pi. Between 0 and pi has a cosine value of negative root 3 over 2. So we need to be in the second quadrant. Cosine value of negative root 3 over 2, that would be a 30-degree reference angle. You can go through all that thought process that you did a couple sections ago, and we should end up with 5 pi over 6. And last but not least, arctangent. What angle between negative pi over 2 and pi over 2 has an undefined tangent value? Let's think about this one. Tangent is sine over cosine. For any fraction to be undefined, we're really trying to figure out what angle between negative pi over 2 and pi over 2 has a cosine value of 0. Okay. Pi over 2 has a cosine value of 0. All right, main things that we learned today: restricted domains, where we have to look here, and then just our basic inverse trig. Inverse trig, giving you a value, asking you at what angle that occurs. How do I know if I should use degrees or radians? Based on the notation. What angles am I looking for in what domain? Here are our restricted domains. All right, we'll finish up. We'll do a lot of examples and in-class discussion.